everyone, FusedVR coming at ya, and so stoked for today. You can see Unity in the background, and we're playing with portals, and who really doesn't love portals? They're so amazing. I've tried them in ARKit, it's awesome. I've tried them in VR, it's awesome. Lots and lots of fun. So I hope you guys enjoy this one, because I'm stoked. And at the end of this one, we'll probably go for about 30 minutes here. If you're joining us live, then you can participate in our creator chat. And we're getting in Adam and Ava from the VR Lab. They've worked on a bunch of different VR projects, both in also audio, with robots, a lot of cool things. So hope you guys are excited for that as well. And we have Ghoster in the chat. And unfortunately, Hassan's not here today in person, but he'll be here in spirit and maybe in the chat as well. So yeah, let's just kind of dive right into this. If you want to follow along, we have the GitHub project in the description. Go ahead and check that out. Also, if you want to participate in any of our creator chats, there's also a link for a form that you can fill out in the description below. So let's just kind of dive into this. We've kind of transitioned to our live streams to be kind of more of like an overview of what that GitHub project actually looks like. And I'll be paying attention to the chat off and on. So if you have suggestions or questions or anything, definitely hit me up there. Let me actually pull up the chat now so I have it here. And I can see a lot of people in there already, so super stoked about that. I love when we have an active chat, so keep that up. So let's start this off. So you can see here in the GitHub project at the top level, we have what I just kind of dubbed as the reverse scene. And I got this asset off the asset store. You can see the skybox here. It's also off the asset store. Really, I mean, it's simple, but I think it works for the theme of kind of this like Tron-esque type of vibe. Let me just double check something. Okay, cool. You can see we have the camera rig right in here, and just a couple assets that kind of came built in with the scene that we got. And let me actually just show this within Unity right now so that you can get a sense of what's going on. The Vive here, game view. Go ahead and turn these controllers on. And so all we have right here, it's just like a giant little robot that is shooting stuff at me. Come on, turn on the controller. There we go. And let me see, I can show it to my head. So on here is a texture that Ghoster made. It's really simple, but kind of just to kind of get that vibe of a actual portal on the background. So that animates in and out based on the particle system. We're using a shuriken for that. And the other side is anytime. Yeah, there we go. So if you look at the actual portal right here, you'll see anytime that it hits a cube, and I'm just throwing cubes here for simplicity's sake, but anytime it hits a cube, then we have a nice little shader here that animates a ripple effect. And I'm going to dive into that because I think shaders are one of those things that, I mean, I'm not particularly good at. I want to get better at them. And you got to start somewhere. So, I mean, a nice simple ripple shader, and I'll dive into that in a little bit. And I'm excited to kind of do a lot more shader programming in the future. So let me know if that's something you want to see. And let's start with the scripts first. This is the texture that Abdo made. It's really nicely done. It works really well for our specific case. And let's go ahead and open this. Wait for Visual Studios to load, because I mean, it's faster than Mono Develop, that's for sure. All right, so, I mean, we really only have two main scripts here. One that controls the shooting, which is basically, I mean, even using just start here, because we don't really need another coroutine. This is something that I find not many people know that you can do, is like you can make your start method a coroutine, which kind of works out nicely in cases like this. So, yeah, we just get the rigid body, we play a sound, like a small little clip there, and we just shoot it off with a standard velocity of about 30, I guess 30 meters per second. It's 30 meters per second because Unity 1 unit equals a meter. And then we just wait a random amount of time for the next one to spawn to just kind of create that interval of actually pushing out objects and kind of making it feel a little random. And then the other script is the one that's actually doing the portal. So let me actually first show it within Unity here. So we've got two portals, one for your left, one for your right hand, and here we go. Just a rigid body on there with the script. We also have the actual mesh here, and you can see already that this is using a custom shader. I put it in the unlit category. You can put it wherever you want. But fundamentally, we didn't want it to get affected by light because there's no really need in this case, so I just made it unlit. And then the other ones here are that particle system that kind of creates that outline around the actual portal, and where it should actually output. And you can see that that is, whoops, let me zoom in. That is like just a little bit in front of it. The reason for it is you don't want to accidentally trigger your the portal back, so then it starts looping, which is something you might have seen in the intros, that you're able to get it looping between the two portals if you position them far enough. Obviously, you don't want it to loop when you don't intend it to, so that's something to keep in mind, and that's one of the reasons why this output is a little further out here. And okay, so that's the reverse portal. It's the same on both sides. You can see here that I am keeping track of which controller the portal should correspond to. So one of them's for the right, one's for the left, and the output is here, and I also tell what portal it should go to next. So in theory, if you wanted to have 3 portals or 4 portals and create kind of a circular loop, or if you wanted to do this in this crazy kind of like catch the potato, which I think, now that I think about it, and I just kind of thought about this right now, that'd be really, really cool if you were like, all right, it's going to come into my right hand and then appear on my friend's left hand, and then you have like 10 or so people in the room. That would be super awesome, actually. So I expect to see someone in the chat post that idea, and I can't wait. Also, yeah, I'm seeing now, if you want to tag me specifically, go ahead and just do an @FusedVR. That makes it pretty obvious. All right, I see shader coding, be awesome. Yeah, and async. And it's something that you don't think of that it should do, but it does, and that's really nice. All right, so that's the reverse portals, and nothing special about the camera rig. And then in the environment, I added that shooter script. You can really toss it anywhere. It just uses your transform as the initial point, and then just shoots in the forward direction of it. So you can rotate it and move it however you want. Okay, so back to the script here. So this is the thing that's on the reverse portal. You saw these public variables that were inside of our script. We've got a bunch of different private variables here, specifically for what happens if multiple objects hit the portal, what happens if what is the portal material, so that we can tell it that something hit it, so it does that ripple effect. Temporary disabling the thing so that it doesn't actually end up re-hitting the same portal. A bunch of different small little tidbits like that. So you can see here, we get the material out of the portal material. And, oh, now I remember. So the hit times here, this is also, again, very specific to the shader, and I'll talk a little bit more about that when I dive into the shader. This one took me probably a few hours to make. Mainly because I don't play with shaders a lot, but I think it was when I got the effect that I wanted, I was excited. So you saw here we didn't actually parent our portal to the controller itself in the scene, so it's not listed under the camera rig. And as a result, we need to actually go ahead and update our position each and every frame using the update and just getting whatever hand we're attached to and moving the position, moving the rotation. So that's something to keep in mind as well. Then, of course, here we have on trigger enter, so we have a collider on it that we've set to a trigger, and whenever any other object hits that portal, and assuming we haven't disabled our firing for whatever reason, specifically in this case to make sure it doesn't re-hit the same portal, then we go ahead, get the rigid body, assuming it has a rigid body, then we fire it into the next portal. And we also go ahead and add a hit time, which again is to make sure we have that ripple effect on our controller. And last part here is just add the hit times and then firing it out. The key to firing it is you want to reverse the velocity based on the direction of that portal. So if it goes in my right controller and then goes out my left controller, where it goes out should depend on, is my left controller facing upwards, is it facing downwards, whatever direction you want. So basically all we did here was, depending on the rotation of the output, we multiply that to the current rotation of our cube, and then that sends it flying. So that's pretty much it from the script standpoint. And if you want to dive into any of these, they're on GitHub, so you can go check that out, manipulate it however you want. But let's go ahead and dive into the meat of this, which is the shader. And so this is a standard vert frag shader. The other option is a surface shader. For this specifically, what we're doing here is making it an unlit one. We have a few properties here, and actually let me show it on the material. That's probably better. At a very high level, I guess I should probably explain shaders. So what shaders is basically code that we can use to manipulate what a material looks like. So you have generally, if you're familiar with Unity, you have the standard shaders. Actually, I can show it here. So you have all these standard shaders. You have a GUI shader, specific shaders for mobile, UI, unlit. If you import in SteamVR, you get it for VR and Valve. So you have a bunch of these different things, but they're all controlled by code, and specifically code that can run on the GPU. And if you're unfamiliar with the hardware, software style, so any scripts you write, they generally will run on the CPU. And I said generally, I think they always do. Your shaders, they're the ones that'll run on the GPU. And basically, you might run into performance issues if you are sending, either you have a lot of materials in your scene, or you're sending a lot of data between the CPU and GPU, and that kind of slows it down. So that's something to keep in mind. And here is basically where you can see all the, like you have scripts that have public properties, you have these properties on shaders that are public, and you can access them from within your C# scripts, you can access them from within the inspector. You can use all of these to manipulate how that input will affect your shader. So let's kind of dive into here. So, I mean, as you can see here, these are all the public properties. They're all reflected here in this properties section. So specifically, I have here the color, any textures you want to provide. In this case, I don't actually use it, but that's something to know. And specifically, you can set it to white as the default. I also have a scale properties, which is basically the scale of how much the ripples actually expand out. And a speed property is how fast they go. The band strength is kind of how thick that line should be. So basically, 3 different properties can kind of control the look and feel of it. Obviously, that ripple is always going to be white. It's something that I kind of set by default in this shader, and you'll see that. But that's also something to keep in mind. Now you have a bunch of code here for subshader and setting them to be in the right layer, how they appear. Specifically, the thing to note here is I do a call off. What that means is typically when you render any game object, what will happen is you will usually, based on wherever the normals are on your mesh, that is where you're going to render. You can do the opposite, which is on the back side, and you can render on the back side of it. This is useful if you're, say, doing a 360 video and you want to reverse your normals. This is one way to do it. Not the most ideal way, but it is one way to do it. And then the last part is specifically if you do call off, which is what we do here, you render on both sides. And as you can see here, I zoomed too much. There we go. If I can render on this side, and I can render on that side. And specifically, actually, I can show you the Blender file. There's nothing terribly fancy about it. Abdo might cringe if he sees it. Oh, do I not have Blender anymore? Oh, I might have uninstalled Blender on this machine. Darn. Oh well. Oh, I have it as an FBX. Well, basically all I did in Blender was I made a circle and then just UV mapped it. That was pretty much it. So it only should render on one side, but because I have this call off on this specific circle, I've actually done it so that it renders on both sides, regardless of the normals. This works kind of well here because it's unlit too. So again, that's something to keep in mind of how this would affect the actual material. And then you have your pass. So the pass is, if you actually look in your stats, I'm going over a lot of shaders because I think they're cool and I kind of want to do more of that because, again, feedback is always welcome. If you go to your stats and you see here, this is a set pass call, that's basically referring to your materials. So any pass within this shader is what's actually going to increase that number of set pass calls. And obviously, you can tell as the higher the number of set pass calls you get, the worse your performance is. So in general, you want to keep the number of passes within the shader pretty small. This becomes really useful actually if you want to go into the nitty-gritty of shaders to actually create a really cool portal with stencil buffers. Basically, if you can do multiple passes, you can create like recursive portals using a stencil buffer. That's really cool. I'm not going to go into it here just because, one, it would take forever to build. Two, it's not something I'm super familiar with. I'm still familiarizing myself with that, but I think it's really, really cool. And yeah, again, for that, you need multiple passes. So, bunch of setup here. Unfortunately, within your shader, they don't know what pi is, so you got to define it yourself. So specifically here, this is what you really want to pay attention to. Actually, no, let me go down a little bit. So these are all the properties that you're going to use within your shader. Using uniform here basically means that your script is able to access this property, so that's good to know. And this is the meat of the shader here. It's a little big. I probably could have optimized it a little more, but it is what it is. And specifically, there are two methods. That's kind of the simplicity of shaders is really only two methods. There's your vert shader, and the second is the frag shader. So what a vert shader does, or not vert shader, vert function does, is it takes all of the verts on your mesh, and for each of those vertices, it'll run it through a function. The beauty here is that because your GPU is a very parallelized machine, if you can call it a machine, because it's a very parallelized machine, what will end up happening is you can basically, for each vertices, you send that to effectively a separate core, which means you can do what would take the CPU forever to do. You can do it really fast. So that's what your vert shader is doing, is going through all those vertices. Next up, and there's really nothing special happening here other than I'm just transforming it to decent coordinates, applying a flog. That's about it. Nothing terribly fancy. This is where the meat of this stuff is happening, and that makes sense because what the frag shader is now that you've what'll end up happening is it calls your vert shader. It does a few more calculations to find what the triangles are, which basically are what are called fragments. And for each fragment, you'll then go ahead and assign a color to it. So that's what your frag shader is doing. This is a lot of code, and I want to see stuff in the chat to tell me if whether or not I should actually do this or not, or like actually explain it. At a high level, what's happening here is this is what I defined or what I said in the scripts. Is this time offsets. So basically, anytime you hit that portal, I register the time, and we use that time to expand out the riffle, which is basically this for loop is looping over all of those time offsets. In this case, I only pick 10. You can kind of vary that however much you want, but 10 seem to be decent for our specific case here. And then you just assign the color based on just the sign function of time. So you're just using time offsets to really figure out what it should be. So there's a lot of a mess of code here. Again, if anyone's actually a really good shader programmer and it's cringing, I apologize. But this is kind of my first somewhat serious dabble into it. All right, so I see a lot of appreciation for shader, so we'll keep that up. So I'm just going to go through a few questions right now. So for Joe, yes, main advantage of a shader is being able to put it on the GPU. In VR, I mean, it offers a lot of optimization possibilities. At the same time, for VR, you're also taxing your GPU a lot over your CPU. Which it's actually like, so you don't want to write too many shaders and too many materials that you're going to overwhelm your GPU. But you can take the time to actually go ahead and optimize the shaders that you put in and optimize the interface between the CPU and GPU to actually maximize performance. So that's the real value of shaders at a very, very, very high level. There's obviously a lot more in there because you can do light calculations and write your own lighting model and make things look much more prettier than you actually could do with just pure Unity C#. But yeah, that is probably also like super advanced, the super advanced version of shaders. Okay, cool. All right, so I'm seeing a lot of excitement for shaders, so this is something I'm going to dabble in a little more. If you have suggestions for what type of shaders, definitely let me know in the comments and the chat. And luckily in our videos, I can actually like look at past videos and like see what the chat says at given time. So I'm watching, so I'm keeping you guys honest on that. So yeah, I mean, you guys saw what the effect of it is, but I guess I can explain this a little more. So basically, and actually Ghoster can explain a lot more what a UV is within a modeling sense. But basically, what it is. and like how you actually build UVs. But what we're using in the shader here is basically a UV is like a number, or specifically two numbers, the U and the V, that allow you to index within a 2D texture. If you have a 3D texture, you can do more. If you have a 1D texture, you just need the U. But that's basically what a UV is. So basically, we're calculating the UV here to basically say, like, this is where we are in the circle as we're passing through our fragments. I want to offset the UV by negative 0.5. The reason being is usually UVs in a model are from 0 to 1. So by offsetting by 0.5, you're basically trying to find that center of your circle. Multiply by the scale, and then we calculate the radius. If we've done circle math, that's what that square root is doing. And then I calculate what I'm calling a z value. Really all that is the color value that I end up using. Or sorry, no, that's the alpha value that I end up using. So you can see here, this is when I end up actually assigning the color. And then I go through for every time offset, basically anytime a ripple is expanded, make sure that we render it out properly, and then we set the alpha of accordingly. You can see that here. Apply fog. Honestly, the apply fog is here mainly because of the fact that I used a ripple shader as a base, which had the fog in it, and then I applied that as well. That's completely optional. I mean, even in this scene, I don't have fog, so it's actually this is one of those things where you might want to optimize it out because it's kind of a waste of GPU power. I mean, if performance is not an issue, as in the case of this scene, like, I mean, we're talking about hardly in like 10K tries. That's nothing. So at least for a PC VR, when you start talking about mobile, yeah, that starts becoming a bigger issue. But yeah, that's the shader in a nutshell. Yeah, I like, if you want to learn more about it, this is an example. Go ahead and use it. Some of the resources I use are just, obviously, I was like, I want a ripple shader effect. Let me Google it. And I was like, cool. All right. So I kind of get at a high level how this works. Unity also has documentation, which I'll actually go ahead and pull up right now. Let's go Unity shader. They have this quote-unquote gentle introduction to shaders. I mean, it's done at a super high level, but you can see here kind of the pipeline of how this works. The different anatomies, properties, the two types of shaders that they really present, cues, that type of thing. So if you want to dive a little more into this, this is a good start. Obviously, with shaders and like the graphics pipeline, there's so much going on. It's like, it's really ridiculous how much things that happen within your renderer that make things happen, and Unity abstracts so much of that unless you go into like the nitty gritty details. So we're super fortunate to have things like Unity and Unreal. So props to those guys for really understanding how our hardware works and making it really abstract for us to use. So yeah, it's crazy. Oh, and this is the other thing I wanted to show. Specifically about portals is I've been actually looking at this thing for how you could actually render specific portals to actually your mesh. So this is a great resource. Actually, let me go ahead and throw this in the chat right now just so you guys have a reference. I'll throw it in the description later. Sweet, that worked. But yeah, this is not the perfect way of implementing it, because I mean, there are caveats that he mentions at the bottom of this. Where are the caveats? Yeah, these are all the caveats, but at the same time, it is free on GitHub. So if you're looking to learn a little bit more, this definitely goes into shaders a lot. So if you're looking to learn a little bit about that, this is a great place to start. Hey, and it looks like we got our creator chats in. So I'm just going to wrap up really fast by going through the chat right here. And yeah, here's a little sneak peek at who we're getting on. Waiting for the cringe. What cringe? Actually, let me pull this up here. You can get double the comments just so you know what I'm looking at. Fusion Grass, they had a texture in alpha. I haven't jumped deep in shaders yet, so yeah. Is Unity supported? So specifically on this, PBR, yeah, so your standard shader is a PBR shader. So if I go to materials, sure, we'll go to this one. This standard shader and the specular setup one, those are PBR textures. You also have your mobile ones if you're trying to really optimize performance. And yeah, and obviously if you're using the lab renderer, those I think have custom shaders as well, specifically to kind of get that more parallax effect that they want for VR, and they do their own custom lighting within it. So that's also something to keep in mind as well. Filters, materials. Yeah, there's a lot of information on shaders. It's kind of crazy. I definitely encourage you. Well, actually, let me go ahead and share that link as well. The Unity General Guide. Gentle shaders. There we go. And this guy. Definitely, if you're like trying to get serious, I think if you're trying to get serious about VR in general, like, you gotta at some point take the dive into shaders. Like, even if you don't touch them often, like even just trying to like create one simple shader, I think is super valuable. That's, as a team, that's kind of something we're figuring out. Just because we're like, oh yeah, we want to make things look a little better. And sometimes the PBR shaders just don't cut it. Baking lights doesn't cut it. You want to add that like little pop that you really only get to do with shaders. I'll mention right now, to be completely fair, is that one of the reasons why some of the Unreal stuff tends to look better is, one, they have a better shader package that people can use, and two, and Ghoster can talk a lot about like the specifics of actually building materials, but their material editor within Unreal is actually really, really good. Think Blueprints except for shaders. So instead of looking at gnarly code like this, you're looking at a material editor. Unity they have things like this called Amplify and Shader Forge, but you do have to pay for them. I happen to have Amplify, which is nice, but yeah, obviously you do have to pay for that, whereas it comes free in Unreal. So those are kind of pros and cons. That's like the super like high level pros and cons of using Unity versus Unreal. You can talk days for that type of stuff. That's one of the crazy parts about it. All right, so we're about 10:30 in. If there aren't any other questions, I'm gonna go ahead and switch to an intermission. I'll be back in about a minute or two, and we'll get Adam on for our creator chat. And so thanks so much. This is Adam and Eva, and I'm FusedVR, and we're signing out. All right, see y'all later.